Welcome to this explainer. If you've ever wondered how a single geographic region can somehow host almost every climate extreme imaginable, well, you are definitely in the right place. Today, we're going to decode the fascinating, hidden mechanics of India's climate. So let's dive right into the massive atmospheric engine of the Indian monsoon.
So, think about this wild paradox for a second. We normally think of a country's climate as being somewhat uniform, right? But how is it possible for one place to experience bone-chilling winter temperatures of -45 degrees Celsius up in Ladakh, while simultaneously places like Chiru and Rajasthan are quite literally burning at 50 degrees on a summer day? It is just a land of absolute contrasts. I mean, you can even find day and night temperature swings of up to 35 degrees in the Thar Desert alone.
And honestly, the plot only thickens when we start talking about rainfall. Get a load of this staggering number: 1,080 centimeters. That is the annual rainfall in places like the Khasi Hills of Meghalaya. To really put that crazy number into perspective, a single day of rain in the Garo Hills can equal 10 whole years of rainfall in Jaisalmer, Rajasthan, which barely scrapes by with 9 centimeters a year. But here's the kicker. Despite these massive regional variations, this entire subcontinent is bound together by one single, powerful rhythmic force, and that's the monsoonal climate.
So, to wrap our heads around this giant puzzle of unity and diversity, we're going to break this explainer into 4 quick parts: a land of extremes, the climate controllers, the mechanics of the monsoon, and finally, the rhythm of seasons.
All right, let's jump straight into part 1, the climate controllers, geographical gears.
Basically, there are 6 distinct geographical gears that run this whole engine. First up, the macro factors. You've got latitude, which places the southern half in the tropics, while the north gets the extremes. Then you have the towering Himalayas literally acting as an invincible shield, blocking freezing Arctic winds. Next, we have thermodynamics. The differential heating between the land and the Indian Ocean creates shifting pressure zones, and a city's distance from the sea entirely dictates if its climate is nice and equitable, like Mumbai, or totally volatile, like Delhi. And finally, local topography kicks in. Altitude and relief explain why 2 cities sitting on the exact same latitude can have wildly different temperatures, or why one side of a mountain gets absolutely drenched while the other side stays bone dry.
Moving right along to part 2, mechanics of the monsoon, the global forces.
Okay, so India's weather isn't just a local thing. It is driven by massive global atmospheric shifts. Enter the ITCZ, or Intertropical Convergence Zone. You can think of this as a giant thermal magnet. During the summer, as the northern landmass heats up, this low-pressure zone actually shifts northwards over the Gangetic Plain. As it moves, it violently pulls southeast trade winds right across the equator. Then, the Earth's rotation, specifically the Coriolis force, deflects them, transforming those winds into the famous, moisture-laden southwest monsoon.
And this is where it gets absolutely crazy, because it perfectly shows how interconnected our entire planet is. A temporary warming way off the coast of Peru in South America, a phenomenon you've probably heard of, El Niño, can actually disrupt this whole system. El Niño increases water temperatures off the South American coast, which distorts the equatorial atmospheric circulation across the globe. For India, this can mean serious delays. A wild El Niño event can push back the onset of the Indian monsoon by up to 12 days across most of the country, which, as you can imagine, directly impacts the livelihoods of millions of farmers. Which brings us to part 3. The rhythm of seasons, the annual cycle.
So, how do these giant global mechanics actually play out for over 1 billion people? Well, it happens through an annual temporal roadmap. It all starts with the cold weather season, which is fueled by continental isolation and these shallow Mediterranean cyclones that bring really vital rain to the north. That eventually gives way to the intense hot weather season, which inevitably breaks into the main event, the southwest monsoon. And finally, the year winds down with the retreating monsoon.
But right before the great rains finally arrive, the tension builds dramatically. The intense heat of the hot weather season, we're talking soaring up to 48 degrees Celsius in the northwest, triggers some incredibly violent localized phenomena. Up north, you get these oppressive dry winds known as the Lu, sweeping across the plains. Meanwhile, the clash of dry and moist air in Bengal creates fierce evening thunderstorms ominously named Kal Baisakhi, which literally translates to the calamity of Baisak. But hey, it's not all bad news. Down south, you get these vital pre-monsoon mango showers in Kerala and blossom showers that essentially wake up the coffee plantations.
Eventually, the tension of that extreme heat finally breaks, and the monsoon formally bursts onto the landmass. Normally, right around June 1st, sudden moisture-heavy winds and violent thunder strike the Kerala coast, dropping temperatures almost instantly. Day by day, you can track the onset dates marching northward as the monsoon aggressively sweeps across the subcontinent until, usually by mid-July, it has engulfed almost the entire country. Now, the physical geography of the region actually forces this massive incoming storm system to split into two distinct branches. First, the Arabian Sea branch slams directly into the steep slopes of the Western Ghats, dumping an immense amount of rainfall on the coastal plains before finally pushing inland. Second, the Bay of Bengal branch sweeps up the east. It actually strikes the coast of Myanmar first, but the Arakan hills act like a giant wall, deflecting the entire storm system right back into West Bengal, Bangladesh, and straight up into the Himalayas.
And that deflected Bay of Bengal branch? It is exactly what funnels an unimaginable amount of moisture directly into the Garo and Khasi hills of Meghalaya. This massive funneling effect is why Monsoon, which sits right on the crest of the Khasi Hills, receives the highest average annual rainfall anywhere in the world. It is just a perfect demonstration of geographical relief, forcing moist air to rise, cool down, and release a truly staggering amount of water. So as September ends and the sun marches south, the low-pressure trough weakens and the monsoon engine basically throws it into reverse. This brings us to the retreating monsoon. The skies clear up, sure, but the land is still incredibly soaked from months of continuous rain. This combo of high temperatures and high humidity creates a very oppressive, sticky weather condition that everyone calls the October heat. And while the rest of the country is finally drying out, the northeast winds start picking up moisture from the Bay of Bengal, finally delivering some much-delayed torrential rain to the Tamil Nadu coast, which ironically stays largely dry during the main summer months.
We've seen just how precise and complex this entire climate engine really is, from the grand shield of the Himalayas to the giant thermal magnet of the ITCZ, all the way down to those regional mango showers. It highlights an absolutely incredible natural balance that literally sustains an entire subcontinent. But, it leaves us with a really critical question. As global climate patterns like El Niño become more and more unpredictable, how is this delicate and vital rhythm going to adapt in the future? It is a fascinating puzzle of atmospheric science, and I highly encourage you to keep exploring this incredible topic. Thanks so much for joining me on this explainer, and I'll catch you in the next one.